Today I am going to discuss on minimum mode configuration of 8086. Based on the signal connected in the MN/MX bar, the microprocessor acts in minimum mode or the maximum mode. If it is MN is 1 or VCC, 8086 is in minimum mode, and if it is 0 or connected to ground, then it is in max mode. Here we are discussing minimum mode pin diagram, and in max mode it is actually microprocessor can be connected to 8087, its coprocessor. But let's discuss minimum mode here. Minimum mode signals can be classified in this way: interrupt service signals. So basically these all signals are interrupt related. Then there is a DMA related signals, hold and HLDA. Then we have memory related signals. Here we have address and data bus, that is multiplex. In the first clock cycle it is acting as address bus. So once it is point the address, then we can use it as data bus. So in the second clock cycle it is acting as data bus, D0 D15. So in the first clock cycle it is acting as address bus, because first we should know, or the microprocessor should know from where to take data or to where to send data, right? So in the first clock cycle it is used as a address bus to send address. Then after first clock cycle it can be used as a data bus. So this multiplexing is done for reducing number of pins, because 8086 is 40 pin IC. But if this multiplexing was not done, then the pin number might have increased. Okay, now let's see each signals one by one. As I already told you, once again I will tell, these signals are interrupt related, and this is for DMA, direct memory access, and this is for address and data bus, and this is for memory operation, memory and IO operation, to connect external world. This is the most important part, so let's discuss this one first: memory or IO control signals. So you can see here arithmetic and address latch enable, bus high enable, memory bar IO bar, data transmit or receive, read bar write bar, data enable, and ready signals. So these are the main control signals. So if you see this diagram, from this diagram this concept will be more clear. So basically in 8086 memory, even it is a 1 megabyte memory interfacing, this memory will be divided into two memory banks. One is odd memory bank and next is even memory bank. Okay, and if you see, as I already told you, as data bus and address bus is multiplexed. So initial stage the address is sent here, okay, and after that this address should be latched, right? So an ALE signal will be sent in this line, so this address will be latched here. So even you change data at this place, the change will not happen at the latch, because the address latch enable signal will be there for only T1 clock cycle. So I will tell you once again, there is a latch here. This latch is for latching the address, okay, because our address and data bus is multiplexed. So in order to point a location in the memory, because for memory read and memory write, you need to point one memory location. In order to point memory location, that address should be latched here. So address latch enable will send a signal and that will latch this address here. So one location might have pointed here. The address will be here that time, output of the latch. After T1 clock cycle, I mean the next stage what you can do, once it is pointed, if there is a data, for example 34, this data can be transferred through data bus. For convenience I didn't connect it, so this is connected, data bus from here and data bus from here, it is connected. So data can be transferred through this data bus, because address is already latched, right? Latch output will be this address. So for that we are sending this address latch enable signal in the T1 clock cycle. In the next let's see what is the use of DT/R bar. Say data can be transferred from memory to microprocessor, or it can be transferred from microprocessor to memory. It depends on the instruction execution, which instruction is executed. So for example, if you are executing an instruction move AX, SI, in this case data is transferring from memory pointed by SI to the AX register. So from memory to 8086 is transferring. So in this case the data transfer direction is controlled by DT/R bar signal. If it is that data is transmitting, then DT will be 1. So if it is a receiving, then DT will be 0. So let's if it is a memory write operation, so what is the direction? From processor to microprocessor, from processor to memory, then what will be DT/R bar? Tell me. So it will be logic 1, because processor is transmitting. Writing means it into the memory, right? So this is controlled by this transceiver, and the transceiver signals are sent from the microprocessor. Suppose a microprocessor is receiving, in this case microprocessor is reading from the memory, so the direction is towards the microprocessor, so it is receiving, this R bar will be 0. So if it is writing into memory, DT will be 1, and if it is receiving, that DT, that signal will be 0. Then we have if it is a read operation, if it is a write operation based on memory read operation, or it is a write operation in conjunction with the memory and IO bar signal. These three signal 3 to 8 decoder convert it as IO read operation or IO write operation or memory read operation or memory write operation based on the instruction. For example, if it is move AX, SI, so this is basically SI is pointing to a memory location, and data should be read from memory to AX register inside. So it is a memory read operation. Suppose this was like this, so it is a memory write operation. So based on the instruction executing in the instruction unit and decoding circuit, so based on the decoding, this decoder will generate these timing signals, and these timing signals will be connected to 3 to 8 decoder, and based on that it will generate the necessary control signals. So this is basically memory and IO control signals. Now let's see timing diagram. You can understand this timing diagram. It's very easy, but with this diagram we'll see this timing diagram together, then it will be very easy. So basically this is a memory write cycle, and main signals are clock cycle. So we have 1, 2, 3, 4. In one memory cycle we have 4 clock cycles. 1, 2, 3, 4. So based on the clock cycle, the transitions are happening. So the first signal is A16 to A19, and signals like S3 status signals. So in the first clock cycle, what will happen? In the first clock cycle, it should be address, right? Because we wanted to locate whether it is memory read or whether it is a memory write. We need to locate that location in the memory. So you need to send the address. So A16 to A19 will be address, and BH signal also will be sent. BH will discuss in this way, because we need to select that memory bank, because here BH is selecting basically the odd bank. I told you it is divided into odd bank and even bank, and chip selection pin of BH chip selection pin of odd bank is connected to BH. So you need to send, if it is a 16-bit operation, you need to send BH signal also. So here in the first case we need to send A16 to A19. So these signals are multiplexed with the status signals. So but in the first clock cycle we need to send the address. So these signals are A16 to A19. So the rest of the address will be in this line. Instead of it is AD0 to AD15, but in the first clock cycle we need to locate that address from where data should be read, or in this case it is write operation, so to where data should be written. So first case it is act as address bus. That's why it is A0 to A15 and A16 to A19. Additionally, we need to send bus high enable to the, because it is connected to the chip selection. It is connected to the chip selection pin of the odd bank. So that is bus high enable. Then rest of the cycle, if you see, it is acting as status signals. So AD0 to AD15, as I told you, initially we need to locate the address where to write. So initially it is act as address bus, then it is act as data bus. 16-bit data will be transferred. 16-bit data will be transferred to the microprocessor, and it is a memory read operation. 16-bit data will be transferred to memory when it is a memory write operation. In this case it is a memory write operation. As I told you, address latch enable will be high during the first clock, because you need to latch this address here, so that till the memory operation it will locate that particular address. Then memory bar, IO bar, as I told you, it's a memory operation. So memory is M is logic 1 and IO bar, so it is a logic 0. So yes, it is a memory operation, it should be logic 1. Suppose if it was a IO write operation, it should be logic 0. Then data transmit or receive, as I told you, here we have a transceiver. If it is a memory write operation, it is a transmit. Okay, here it is memory write operation, so it is transmit. If it is a memory read operation, then it is receiving, right? So here it is a memory write operation, so it is a transmit. So transmit means here again transmit is logic 1 and 0 represent receive. So here it is transmit. Then read bar. So if you want to represent read, then your signal should be logic low, but it is write operation, so it is logic 1. And as it is a write operation, after locating, see, after the address is sent, see, before sending the address, no need to write anything, right? Because we need to locate where we wanted to write. So after locating the location, then we will enable the write operation, because as it is a logic low signal, we represent logic low during the write operation. Then data enabled, so data will be stopped by using this DEN signal in transceiver. So when same way, when the address is locating that location, after that we will enable the data to be transferred to the data bus. So this is the timing diagram of 8086 in minimum mode. It is a write cycle. Suppose what will be the change? Suppose if it is a read operation, let's see what will be the change. If it is a read operation, if it is a memory read operation, then what happens? See, all these signals are same. It is a memory operation, but instead of transmit, memory read means it is a receive. So this signal will be low. And as it is a read operation, and this read signal also will be low here, because after locating the address location only, we need to make this low. So here it will be low. Then data enable, as it is, write bar will be logic 1. Here it will be logic 1. Instead of, it will not go down here, because it is as it is a read operation expression. So I am not writing here drawing here a read memory cycle. You can convert this into memory read cycle. So thank you.